Perovskite solar cells are a type of solar cell. They are a new type of compound, thin-film solar cell that uses perovskite-type materials as the light-absorbing layer. Perovskite solar cells have high photoelectric conversion efficiency. The theoretical maximum conversion efficiency of single-junction perovskite solar cells reaches 31%. The theoretical efficiency of multi-junction perovskite solar cells exceeds 50%, which is about 1.5 times that of current crystalline silicon solar cells. Perovskite does not specifically refer to a certain compound containing calcium and titanium, but is a general term for a class of crystal materials with an ABX structure. There are many material options available. The most commonly used are hybrid organic-inorganic lead or tin halide materials as the light-absorbing active layer. Perovskite materials such as methylammonium, lead halide, and all-inorganic cesium halide are inexpensive to produce and easy to manufacture. In modules, the thickness of the perovskite layer is very thin, 0.1 to 0.5 micrometers, compared with crystalline silicon solar cells at 130 to 170 micrometers. The difference exceeds 300 times, consuming less material and resulting in lower cost. Perovskite solar cells have advantages such as being lightweight, having strong transparency, strong short wavelength light absorption capability, good low light performance, and the ability to be prepared on flexible substrates. As a representative of the third generation non-silicon thin film solar cells, perovskite requires less material for fabrication, has a short industrial chain. Perovskite solar cells only require one factory. From glass, encapsulation film, targets, and chemical raw materials entering to module formation, the total process only takes 45 minutes. They have broad application prospects.